So I'm John Gudmundson in product marketing on the A10 team. And I rather imagine that some of you here, maybe all of you, are involved with SSL certificate management to some degree or another. It's very critical that you have a smooth operating certificate management system. But we know it's not particularly easy. I mean, it's a very complicated task. But it takes much more than just a really good SSL certificate management tool. Now, we at A10 don't provide those types of tools. We provide what we call our app delivery controllers and some other capabilities that I'll talk about. But it's in this day and age, it's far more important than ever that you have a really good tool, a really good infrastructure that can handle SSL traffic management. And the reason why that's the case is that the use of SSL traffic is basically exploding. So if you look at the digital content of the world, so to speak, it's projected to grow by a factor of 50 over roughly a 10-year period of time. So an inordinate amount of digital content out there. Then if you look at the IP traffic, it's actually over a 5-year period, it's expected to triple. I don't think these statistics will astound anybody. You've probably seen this many times in recent years. And also, the Internet of Things that some of you have obviously heard about, and it's growing. And if you don't have a digitally connected car today, I'm sure you probably will in the near future. And in terms of the Internet of Things, it's projected to grow by a factor of 5 over about a 10-year period. But what's kind of more recent is the use and the growth of SSL encrypted traffic. It's projected over roughly a 5-year period to grow to about 35% of the actual traffic. But what's recently happened is you're seeing some of the big web providers such as Google and Yahoo actually utilizing or turning on SSL by default. You're also seeing ordinary common web browsers, just your typical citizens out there, using virtual private networks with SSL. So it's not just for kind of the professionals in the tech industry, it's kind of for everybody. So it's clear that the use of SSL traffic is going to grow. And at this point, a number of sources like NSS Labs claims that enterprise data today is typically a good 35% SSL, with some enterprises utilizing over 70% of the traffic being SSL encrypted. So it's imperative that you have something that can scale to match those types of needs. Now, with increased security comes obviously a lot of difficulties, a lot of complexity, and a lot of challenges. And obviously you could list probably multiple slides with all the challenges you face when it comes to certificate management. So it's a short presentation, I can't go through it all, but let me just point out a few of these. So it starts with obviously knowing where your certificates are, knowing if they're valid, knowing if they're expired or not, knowing their status. And in addition to that, you have to be able to kind of, not only where they are, but you've got to be interoperable with all these other network infrastructure elements in your environment that will have SSL on them. So these tools have to be working literally with routers and servers and next-gen firewalls and you name it. So there's a whole interoperability key, such that if your certificate intelligence system doesn't really work that well, or at least doesn't interoperate with all these other types of devices out there, then it's not of much use. You also have to deal with the compliance and standards issues. Now, one thing today is that you're seeing, and have probably already dealt with the fact that, say, SHA-1 is now moving on to SSH-2, whether you like it or not. That's where it's going. But there's many more standards out there that you may be familiar with or using, such as elliptic curve cryptography or perfect forward secrecy, and a whole slew of other things that you're probably aware of, may already have deployed, or you're looking to do so. Another challenge is what I call multi-tenant environments. Now, a little bit later, I'll be talking a little more, elaborate more on what that is. But suffice to say for now that that's not something that, well, I'm not a cloud provider, I'm not a web hosting provider, I'm just an ordinary enterprise. I don't need to worry about multi-tenancy. The fact is that multi-tenancy has got tremendous amount of value, and if you're not using it today, you probably will be in the not too distant future. Now, legacy environments, what you'll find is oftentimes a certificate management tool has to be manually configured to determine where the certificates are. And this, of course, involves importing, exporting of certs, It involves renewals and backups and a whole slew of other administrative tasks that make your life more difficult. And it comes all the more critical when you're dealing with network firewalls, intrusion prevention, and so forth, such that there's a possibility at least that you wind up getting errors or misconfigurations. So it's not an easy process when you're manually working with all these different types of devices out there. Now, just a kind of a quick look at SHA-1, just as an example about how standards are changing. And you can see here from a timeline that pretty much SHA-1 is going to be pretty much defunct in the very near future. But as I mentioned, there's other standards as well that you have to be able to deal with and to manage with your certificate management solutions. Now, there is there's a way to help improve the discovery process, centralize your ability to manage certificates and whatnot, and that actually comes from what we call a next-gen or layer 7 aware application delivery controller device. So let me talk a little bit about what we do. So at A10, like I said, we don't actually sell or provide certificate management solutions. We partner with companies that do so. But we provide what we call our application delivery controllers. And if you're not familiar with that term, basically there's three primary benefits that these devices provide. One is availability. And what I mean by that is the ability that when a client comes into your data center looking for data, looking to be authenticated and whatnot, the servers are actually available to that user. So you're using health checks behind the scenes, you're using very sophisticated layer 4 through layer 7 load balancing to ensure that the request when it comes in goes to the actual server that can best handle that response and then get the data back to the end user. And this can be on a local or a global scale. So with global server load balancing, even if you've got multiple data centers and one of them, heaven forbid, goes down with an earthquake or a terrorist attack or something, we can ensure business continuity by having requests automatically redirected to other sites, other data centers, literally around the world, and it's transparent to the user. So availability is a big key, and ultimately what you can do is actually knock out a good half of your servers in your server farm because you're making it much more efficient in terms of how traffic is being managed. So it's very, very intelligent traffic management going on behind the scenes. Another thing is acceleration. So I rather imagine some or all of you utilize applications that we all know to be kind of chatty and inefficient. And we also know that you've got a lot of customers, partners, employees around the world that are utilizing these applications. And if there's no way to make them improve the response times of the data that goes back to these people who are requesting data, then the applications will run slow. They'll be either kind of your productivity drops, or literally the applications don't work at all because the distances involved, latencies, and so forth. So what we do within our application delivery controllers is we provide a whole slew of what we call WAN protocol optimization techniques, such as client keep alive, selective acknowledgement, fast ramp, a number of things that utilize fully standardized, quote unquote, RFC standards to ensure that these applications and the responses that go back to the end user are accelerated to make the applications sometimes appear as if they're literally local on a particular local area network. So you can achieve your service layer agreements. And we offload a lot of the TCP/IP, the bulk of it, off your servers. We offload the SSL processing, authentication, and a whole slew of other things onto ADCs to, in fact, make the servers more efficient and ultimately accelerate the content back to the user. We also have caching, dynamic and static caching, which again makes it such that the user doesn't actually have to go all the way to the server. They just have to go to the ADC, and the data gets sent back to the client. We have compression, which can drive down the WAN bandwidth requirements, which indirectly also makes the internet more efficient because you're actually throwing less data through the pipe, if you will, and it can actually improve the efficiency. Less blocking of packets and things are going on, so that ultimately you get better acceleration. Now, being how this is RSA and security is a critical interest of you guys, I want to talk about how we involve ourselves in security. Now, many of you, if not most of you, use either a next-gen network firewall, or you utilize some sort of, obviously, intrusion prevention systems, or unified threat management, endpoint security, and on to prevent malware and all that. And that's all great, and those are great solutions. But the one thing that none of these guys do is actually stop attacks that are directed at the applications themselves and the weaknesses of those applications. So such things as a SQL injection attack, or forceful browsing, or cookie poisoning, cross-site request forgery. There's dozens of so-called day zero attacks that an IPS or a next-gen firewall is not going to stop, because they're targeting the vulnerabilities of the applications themselves. So Web App Firewall, which is part of our app delivery controllers, provides that. We also, as you may have heard some other sessions here, we provide very high capacity protection against DDoS and protocol anomaly attacks. And ultimately, if you're in the financial services industry and some other, healthcare, oftentimes you either have to have a web app firewall in your network, or a constant code audit to ensure that your applications are in fact been certified as being, basically not vulnerable to attacks. Now, what's great about these is you get all of this in a one compact appliance. Compact meaning 1 or 2 rack unit appliance that can actually support over 100 gigabits per second of layer 7 throughput. And you can do all these features all simultaneously. Unlike some vendors in this industry, where if you start throwing a few particular modules like compression or caching or whatnot on the same box, the box crashes. With A10, you can do everything all at once at very high throughputs. When we talk about SSL, which is of paramount importance to the group here, we can actually process into the tens of gigabits per second of sustained SSL traffic, even with 2K, 4K, and higher key lengths. And also, if you're concerned about the number of transactions per second, we can provide support over several 100,000 SSL transactions per second, again, with these higher key lengths. So, like I said, it's pretty everything, and kind of think of it as like the Swiss Army knife of networking and security products. Now, it also, like I said, it works with many of the SSL standards out there, which I'll talk a little bit more about in a minute. And normally where you'll see an ADC, an app delivery controller, is deep in your network near your web and application firewalls, but you'll also find them sometimes in the DMZ. Now let's take a look at automating certificate management. Now, by having an A10 device in here, what you can do is centralize all these SSL certificates from the servers and put them on the A10 box. So as I mentioned, A10 is sitting there doing all this heavy loading of SSL traffic processing. So it stands to reason the certs have to be there. But they don't have to be on your overworked servers. So that, again, centralizes and really helps your certificate management solution determine where those certs are. So rather than this guy having to run out everywhere in your network and finding these digital certificates, it can literally go to one box here and find them. And it does that by what we call our AX API, which is simply our version of an application programming interface that smooths the interoperability, if you want to call it that way, or just the interaction between various central certificate management solutions and the ADC. So this helps the certificate management solution do all the normal functions it normally does, renewing, backup, and all the other stuff involved with certificate management. Now, if it turns out that a particular certificate is expired and it needs to go get another one, your cert management solution can go to a certificate authority, whichever one happens to be, and get a renewed certificate. So, in essence, what you've got is a very smooth operating system between one particular certificate management solution and the ADC device. Now, let me talk about multi-tenancy. As I mentioned at the outset, this is something that more and more of you, if you're not using it today, you'll probably be using in the very near future. And one thing that's great about multi-tenancy is the ability to effectively take one app delivery controller and chop it up into multiple kind of independent ADCs. And in the case of our HVA models, you can have up to 40 instances where each instance gets its exact amount or a specific amount of the CPU, SSL, IO, and memory, such that that instance and the applications and what's going on there cannot possibly impact another one. You can't have one instance starve a second one and so forth. Or with our ADPs, application delivery partitions, you can basically slice and dice this box up into over 1,000 different instances. Now in that case, each instance isn't completely 100% isolated, but in the vast majority of business use cases, it's good enough. It's virtually isolated. So when you have this multi-tenancy, each one of these partitions can get a particular set of policies. So that, let's say you've got a set of users on ADP 1. Say you're running certain applications for certain users, and you want to have you want to configure your policies to optimize those applications and users. A second ADP can be a separate set of applications and users, and so on. So it gives you that high granularity to be able to support users in a very specific way. So one could be running Exchange, one could be running Link, one could be running whatever. Or you could have mobile devices that need a certain type of configuration, and those could be set to a particular instance. So that's the value of multi-tenancy. But the concern there is, well, all right, but if I implement multi-tenancy, is my certificate management box going to work with all these different instances? Well, the answer is yes. We have been fully validated and certified with a number of the certificate management vendors out there, many of which are at the show today, such that when you have to do a number of tasks, like the certificate management wants to monitor each one of these instances, you can do it independently of each other. Same thing for the for renewal certificates, again, one by one on all the different instances, so they don't interfere with each other, if you will. And the same thing for backup. So again, it's just, think of it as scaling. It's a one instance. You've got potentially over 1,000 of them, and your cert management tools still work with that with no issues. Now, let me talk about the various standards out there. And as I mentioned up front about elliptic curve cryptography, this is one of the more newer techniques, and it's really quite amazing the fact that this has way more security than your typical RSA with 2,000-bit length keys. In fact, a ECC 256 curve is 10,000 times more secure than RSA with 2,000 bits. So it's something that if you don't have it today, you'll probably implement it at some point in the future. And rest assured that this is supported on our ADC box. And again, because of the offloading of all this SSL processing onto the ADC, what that does is minimizes all the rest of your infrastructure, your cert management and so forth, so that you basically can be able to power this as opposed to on some alternative solutions that don't have that capability. And perfect forward secrecy, again, a relatively recent standard that's being more and more deployed. What's really nice about this is it's almost impossible to break into this thing. And even if somehow somebody can break in, they'll only be able to get one session and maybe go back one message. But since the keys are constantly changing, it's, for them to literally be able to encrypt and steal the data in a full session would be essentially impossible to happen. So it's a very powerful tool, and more of the advanced certificate management solutions support that, as we do at A10. So one last thing I want to talk about is, I mentioned about taking the number of servers in your network and basically cutting them in half or more. So at this point, without something like an ADC from A10, you've got all these different servers out there. They've got all these digital certificates, having to do all this SSL processing locally. But with an A10 box, because of the intelligent traffic management capabilities that we have, like I said, you can pretty much cut in half the number of servers in your server farm. We've got many customers, and it's not just us, it's even other vendors of ADC will tell you the same thing, that by using intelligent traffic management capabilities, you can shrink your server farm down dramatically. And then, of course, you can take all the certs, throw them onto the A10 box. So that simplifies the network as well.